Okay, we're going to take notes as you go here today, okay? So don't write ahead, just write with me, okay? What we just calculated here, what we were talking about, has a special name in statistics, and it's called the measure of relative standing. Okay? Also known as the z-score. The z-score represents how many standard deviations away you are from the mean. And you guys just told me if you're more standard deviations away from the mean, you did better than someone who's not. So how do we calculate this measurement? Okay, well, I mean, it would have been pretty easy. Let's say the mean of a bunch of scores was 60 and the standard deviation was 4. Okay, let's say I got a score of 64. You guys could do this one in your head, right? How many standard deviations away from the mean are you here? Just one, right? One standard deviation away. But what if this score was 65? What mathematically would you have to do to calculate how many standard deviations away from the mean you are here? Yeah.
Take your mean and subtract that number so you get 5.
Okay, so this one minus the mean, so you're 5 points away from the mean.
And then divide that by your standard deviation.
And then divide by the standard deviation. Okay, and that would tell you how many standard deviations away you are. A little bit more than 1. We're actually going to have a decimal here. Okay. So this is how we can determine how many standard deviations away we are from the mean at any particular time. Okay. All right, now, let's get a little bit trickier now. So let's say I do in fact have a normal distribution with a mean of 60 and a standard deviation of 4. And let's say I got a score of 65 and I want to know what percentile that puts me in. Okay, draw your picture. All right, remember what I need here now. I need the mean. I need your score. Okay, and I need you to shade that region. That's what I'm looking for. Now, a lot of you did this. Yesterday, for fun, I said, hey, if you want to, just put a 1 there. And a lot of you did that last night, saying that you were 1 standard deviation from the mean. Okay, well, that's what we're going to do now. We're going to put how many standard deviations you are away from the mean right below the actual numbers. So let's think about this a second. How many standard deviations away from the mean are you if you are the mean? Yeah, I mean, put in your formula, right? 60 minus 60. So we're always going to have a 0 here. And our next step is we need to calculate how many standard deviations away from the mean that we are here. So your next step is going to be to write the formula, plug in the appropriate numbers, and then do the math. We're going to round to the hundredths place. Now remember, if you put this in your calculator, put parentheses around it. Either that or enter the top and then hit enter. So what do we have as our z-score here?
1.25.
Yeah, we're going to go to the hundredths place. And now I've completed my picture. Okay, I've fully completed my picture. Now we have a problem. You can go figure this out. Okay, so you don't have a problem? Okay, what's the answer? This. What's the percentile if you got a score of 65?
That's not what I thought you were just going to be how many standard deviations.
Do you have a problem now, though, trying to find that percentile?
Yes.
Why? What's your problem? Why can't we do that? It's not our fancy rule we learned yesterday, right? We learned the percentage of scores that were between exactly 1 standard deviation from the mean We learn the percentage of scores that are exactly within 2 standard deviations of the mean, and we learn the percentage of scores that are within 3 standard deviations from the mean. But we don't know all the other ones in between until today. Go get out your green sheets, and it's pages 14 and 15, and put them right in front of you. I put them on opposite pages so you can look at them right in front of you. This is the 68, 95, 99.7 rule on steroids. This gives us every situation. All right, let me show you what we've got here on this chart. On top here is a picture of a normal curve, and they have the percentile shaded. Those percentiles are found in here. Okay? On the far left-hand side and the top are the z-scores. On the left-hand side, it gives you the first 2 digits, 1.2. And on the top, it gives you the hundredths place. So to find 1.25, we would go to that spot. I'll show you that in a second. Now, on page 14, it gives you the percentiles for the negative z-scores. Remember, z-scores can be positive or negative, depending on whether you're above or below the mean. And on the page 15, you'll see the positive z-scores over there. Now, just to show you that this works, you guys should know this one by now. If you're 1 standard deviation away from the mean, what is that percentile? Go back to our 68, 84. What do you got?
84%.
Remember, isn't that 84%, or can I say 0.8400? Isn't that 84%? Because that's how you're going to read them in here. Go find 1 standard deviation. So go look up a z-score of 1.00. Everybody go find that spot. So you're looking up positive 1.00. So you go down to 1.0. You don't go over at all. And what number do you see there? 0.8413. Has everybody got that spot? That's the precise percentile. 84% was just an approximation. That's the exact percentile if you're exactly 1 standard deviation above the mean. Yes.
How come the z-score only goes up to 3.4? Does that
Well, think about that. Think about it. 3.4 is as big as it goes. Well, first of all, don't we know 99.7% is within 3 standard deviations of the mean? So when you get out there,
Absolutely.
you're not going to have any numbers out there. Say, almost impossible is what they're saying there. Okay? All right, so now go find the answer to this. You should not have a problem now. So go find the percentile if you're 1.25 standard deviations above the mean. So you go down to the 1.2, but now you got to go over to the hundredths place. I know it's got to be more than 84%, right? Because I did better than 1 standard deviation from the mean. What'd you come up with? Monica.
0.8944.
Is she right? Is it 0.8944? Has everybody got that? Knows where it is? So your sentence would be that a score of 65 would put you in the 89.44th percentile. All right, let's get a little bit more interesting here. Now I want to know what percentage of scores are, I don't know, between 54 and 61. What percentage of scores are between 54 and 61? Go. So what's the first thing we're going to do? Draw a picture. So draw me a picture. Draw a correct picture for this situation. It's a normal distribution. Shade correctly. We got to do some calculating now after we shade, right? What are we calculating? Standard deviation. deviations from the mean that you are. Yeah, it's called the z-score. So you just have to write the formula once, and then you can plug in 2 sets of numbers to go get your z-scores, and then put them on your picture. Careful with your calculator, put a parenthesis around the top, just do the top, hit enter, and then do your divide. Okay, Haley, work with me here now. So here's the z-score formula. This needs to be on your paper. Every time you're going to use it in a new problem, write the formula down. All right, so the first one, what do I plug in? 54 minus over, and what would that come out to? Try that one again. You say 0.25? No way. First of all, is this going to be a positive or a negative number? You're on the wrong one. Yeah. What's this one?
Or 1.5.
Say it again.
Negative.
Negative 1.50. Okay, right? We're below the mean, aren't we? Okay. So right down here, I'll put 0 at the mean. This is negative 1.50. We're negative 1.5 standard deviations from the mean. Now, you don't have to write the formula again, but plug in the numbers. 61 minus 60 over 4. I think you already said that. 0.25. So we got 0.25. Now we have a problem. How in the world are you going to use those charts to calculate that percentage of scores? All right, Nolan, what'd you do?
You would find the difference in the percentiles.
Okay, so how are you going to do that?
Well, you're going to look up your chart, the top one, and then find
So
out.
that's going to give you all the way over, right? Then you're going to look up this one, and it's going to give you all the way over, and then what do you want to do with those two?
You're going to subtract it.
Yeah, does that make sense? So I've got this whole percentile, and I want to get rid of that percentile, which is what they give you. Did you get those two numbers yet?
No, I don't.
Okay, let's go look those up now. So you're looking up 0.25, you're looking up negative 1.5, and you're finding the percentiles of being that far away. Okay, what'd you get?
For 0.25, it's 0.5987.
Okay, minus.
The other one is 0.0668.
Is that correct over there? Is that right? Yeah. So what'd you get in there?
0.5319.
5319. And then we write that up in a sentence. The percentage of test scores that are between a 54 and 61 is around 53.19%. Okay. All right, these numbers we're putting down here, the z-scores, they kind of have a fancy name too. It's called the standard normal curve. Okay, we write 2 sets of numbers on our curves. We write the actual data, and then we convert those to normalized data, standardized data. Okay, we always know the mean of the standardized score. What's the mean? What's the mean of the mean going to be? It's 0. And then 1 standard deviation away is where those inflection points will be. Okay, so we have the actual data, we have the standardized score data here, the z-scores. All right, this is one where a picture might help you out a little bit. You don't know what you're doing. They will ask these questions so many different ways. Okay, your pictures will help you. We'll see if it helps you here. what score will put you in the 82nd percentile? What test score will put you in the 82nd percentile? What kind of a picture would you build here? Now remember, I want all the details from the question in the picture. Then you continue from there to build the picture all you can. Question? 82nd percentile. What test score puts you in the 82nd percentile? So just start building your picture. Okay, you don't even have to think much. Just start building your picture. You look at your picture, think about your charts, maybe some things will come to you. So now you've got two rows of numbers to fill in. You've got actual data and you've got the standardized score data. I'm supposed to put in the mean, I know that. Okay, so 82nd percentile, that's not one of our fancy numbers. 84 percentile would have been nice, right? That's the whole 1, 2, 3 standard deviation. So I don't know what this is. I do know that this is supposed to be 80%, or 0.8000. Do I know what this is? Do I know the z-score at 60?
Yes.
What is it? Okay. Do I know what this is? Do I know what this is?
Yes.
I got half of you saying yes, I got half of you saying no. The answer is yes. You should be able to find that. You do know that. Go back to your tables. On the outsides are the z-scores, correct? What's on the inside? I don't know. What's on the inside here? What do these represent? The percentiles, don't they? So we need to search in here for 80%. Now, is there any one of them that are exactly 80%? Go look. Do you find 0.8000? So just find the closest one and that's fine for now. So which z-score is the closest? How many standard deviations from the mean do you need to be 80% of the scores? I don't think so. 0.85?
Yeah.
You started off saying 82nd.
Yeah, you said
At the beginning you said 82nd.
Oh, I'm sorry. Okay. So you guys were doing 82nd percentile?
Yeah.
Okay. All right. So I'm looking for 8200. There we are. 0.82. Okay. So I see.
0.92?
All right. I see 0.1, 0.8186, and 0.8212. I guess the closer one would be 0.92. Okay. We'll refine that a little bit later. But yeah, I can find this now. That is findable. Okay, and this is where the picture might help you see that, okay? Now, next step is, yeah. Yes. Well, first you're going to write down the z-score formula. Z is equal to mean to the average, to the number minus standard deviation, minus the mean over standard deviation. Question. I've got 4 variables here. Do I know 3 of them?
Yes.
Yeah, you actually do. What is the z-score for this problem? And that's what you had to go calculate, right? Or find on your chart. What is the x value, the number we're looking for? No. Do we know the mean?
60.
And do we know standard deviation? Absolutely. All right, the book kind of manipulates this formula. I don't want you to. Just write the basic formula down and then find the things that you do know. See to try to figure out the ones you don't know. All right, a little algebra 1 problem here. What would I do first? Multiply by 4. So it's 4 times 0.92 is equal to 40 minus 60, and then add your 60 and you get it.
You want to round it all or just keep it that bit? 'Cause it's not
Round, where are you rounding?
with the final answer because it's not exactly.
Yeah, you rounded a little bit here. I would give whatever that answer is. That's fine. Okay, so you got to know the chart backwards and forwards here. Let me ask you this question. What if I was asking you for that percentage? How would you use the chart to figure out the percentage that's over there? Okay, so what do you got?
Find the percentile of the left side and subtract from 100.
Good, and subtract from 100, or 1, right? These are given in decimals, so just subtract. Okay? Okay, so you're going to do a bunch of these types of problems tonight. Z-score, remember, it's a measure of relative standing. For number 2, just go calculate the Z-scores. Remember, you can't draw a normal curve, you can't find percentiles here. If this was a normal curve, you could just go find the percentiles, you know you'd beat a higher percentage. But you don't need that. All you need is Z-score. Let me give you an example. I'm probably going to be talking to about 2 of you right now. Years ago, I used to play fantasy baseball. Okay, maybe some of you play fantasy football now. So, again, I'm probably talking to 2 of you, but hang with me, the 2 of you that are watching. What's the biggest problem when you're playing fantasy, whatever? It's the draft, and the question is, I'll do baseball right now. Do I pick an outfielder or do I pick a third baseman next? Right? You have the same problem in fantasy football, right? Do I kicker or do I? So here's what I did. So here's the deal. Outfielders generally score way more points. They're better hitters, they score more points than like a second baseman would. Okay, so people just say, oh, I'll just keep picking outfielders because, they'll score more points. Well, here's the deal. There's a lot of outfielders that score a lot of points. But the second baseman, maybe their relative difference is a lot bigger. So here's what I did. For each position, I calculated the player's Z-score. Took all the outfielders and calculated all their Z-scores. Figured out the mean for the outfielders, got all their Z-scores. Then I did all the third basemen and found their Z-scores. And I found all the second basemen and got their Z-scores. So what I did at certain parts of the draft, when other people were still doing outfielders, I knew that there were a lot of Z-scores close together up here. But in second baseman, there might be a second baseman, and their relative difference to the other second baseman was huge. Then I just sorted all the Z-scores. So I had my draft order. I would be drafting like some shortstop ahead of some outfielder because I know I could get an outfielder later, but that shortstop was way better than the other shortstops relatively. I won 2 championships, came in second the other year. We had a founding father come in here last period. He just did fantasy football. He did the Z-score thing. And his draft, you look at this draft, I don't know if you're in any of your fantasy football, but they do projections. Yeah. He was by far better than any other team. So you didn't think this stuff would ever help you in real life, right? It's actually made me some money. Okay? This is a big deal. When you guys go to college, okay, and you're going to come, you're going to email me, and I'm going to ask you how'd you do on your first test. I don't want to know your score. Oh, I got an 80. That tells me nothing, right? It could be out of 1,000. If I know the mean, that tells me, well, I'm going to ask you what's your Z-score. You better not tell me a negative number. A couple of you are laughing. You know what that means. Negative number, right? You'd be below the mean. Okay? So Z-score is a big deal. Okay. All right.